Previous session we have discussed normal distribution. This session we will cover skewness and kurtosis, also Pearson first and second coefficient. Skewness and kurtosis. Skewness and kurtosis are two important statistics measures that describe the shape and characteristics of a distribution. They provide insight into the asymmetry and peakedness of the data respectively. Skewness measures the asymmetry of a distribution. It indicates whether the data is skewed to the left or right of the mean. Skewness is used to measure the level of asymmetry in our graph. It is the measure of asymmetry that occurs when our data deviates from the norms. There are three types of skewness. Zero skewness, that is symmetric skewness, positive and negative skewness, both are part of asymmetric skewness. Zero skewness or symmetric skewness. A distribution with zero skewness is symmetric with value evenly centered around the mean. The mean, median and mode are all at the center point. Here you can see mean equal to median equal to mode. Actually values evenly centered around the mean. Asymmetric skewness. The frequency curve is more stretched towards one side. Values of mean, median and mode both at different point. Positive skewness. In this, the concentration of frequencies are more towards higher values of the variable, so that the right tail is longer than left tail. That is your left tail, it's your right tail. Right tail. So right tail is longer than left tail. Negative skewness. In this, the concentration of frequencies are more towards the lower values of the variable. So left tail is longer than the right tail. This one left tail, left tail is longer than right tail. Skewness measures the shape of the distribution. A distribution is symmetrical when the proportion of data at an equal distance from the mean or median is equal. If the values extend to the right, it is right skewed, and if the values extend to left, it is left skewed. Pearson first coefficient. The median is always the middle value and the mean and mode are the extremes. So you can derive a formula to capture the horizontal distance between mean and mode. Pearson of first coefficient equal to mean minus mode by standard deviation. The above formula gives you Pearson first coefficient. This formula gives you Pearson first coefficient. Division by the standard deviation will help you scale down the difference between mode and mean. This will scale down their values in a range of -1 to 1. Now understand the relation between mode, mean and median. Mode in terms of mean and median, that is mode equal to 3 median minus 2 mean. If I put this value here, so we can get Pearson second coefficient. Mode equal to 3 median minus 2 mean. So substituting this in Pearson first coefficient gives us Pearson second coefficient, and the formula for skewness, Pearson second coefficient equal to 3 mean minus median by standard deviation. Here you can see mean minus 3 median and 2 mean by standard deviation then you can get 3 median mean minus, so then you can get mean minus 3 median plus 2 mean by standard deviation. So 3 mean minus 3 median by standard deviation mean. So you can get common 3 from both. Now 3 mean minus median by standard deviation, that is your Pearson second coefficient. If this value is between minus 0.5 and 0.5, the distribution of the value is almost symmetrical, and if the value is between minus 1 and minus 0.5, the data is negatively skewed, and if it is between 0.5 to 1, the data is positively skewed. The skewness is moderate. If the skewness is lower than minus 1, that is negative skewed, or greater than 1, that is positive skewed, the data is highly skewed. Come to kurtosis. Kurtosis in statistics is used to check whether the tail of the given distribution have extreme values. It also represents the shape of the probability distribution. So kurtosis is a character of the frequency distribution. It gives an idea about the shape of frequency distribution. The measure of kurtosis is the extent to which a frequency distribution is peaked in comparison with a normal curve. It's the degree of peakedness of a distribution. That is the main important thing. It's a degree of peakedness. The kurtosis leptokurtic, mesokurtic and platykurtic. Leptokurtic. Leptokurtic is a curve having a high peak than the normal distribution in the curve. There is too much concentration of items near the central value. You can see this one leptokurtic and too much concentration of items near central value. This is your central value. Mesokurtic. Mesokurtic is a curve having a normal peak than the normal curve in this curve. So this one your mesokurtic. There is equal distribution of items around the central value. You can see left side and right side. This is left side, this is right side. It's an equal distribution. Platykurtic. Platykurtic is a curve having a low peak than the normal curve. It's called platykurtic. This one mesokurtic just like a normal curve or platykurtic. You can see height of the curve is lower than the normal curve. In this curve, there is less concentration of items around the central value compared to meso or leptokurtic. Here is less concentration of item around the central value. Somewhere another things you can get excess kurtosis. Expected value of kurtosis is 3. This is observed in a symmetric distribution. A kurtosis greater than the 3 will indicate positive kurtosis. In this case, the value of kurtosis will range from 1 to infinity. Further, a kurtosis less than 3 will mean a negative kurtosis. The range of a negative kurtosis is from -2 to infinity. The greater of the value of kurtosis, the higher the peak. So, excess kurtosis equal to kurtosis minus 3. Now come to key differences between skewness and kurtosis. Skewness measure the asymmetry of a distribution, indicating whether the data is skewed to the left or right. Kurtosis measures the peakedness or flatness, of a distribution, indicating how much data is concentrated around the mean and how the tails compare to a normal distribution.